Alright, welcome back everyone to the part 2 of graphing sine and cosine functions. Let's go ahead and dive right on in there and take a look at our first example today. Alright, y equals 3 cosine of x over 2 plus pi minus 1. Let's go ahead and dive right in here with this example. Let's go ahead and get our wonderful graph drawn. Alright, and as we know, the first thing I like to do is to get that parent function drawn, right? So I'm going to actually draw our steps over here. Step 1 is to get that parent, Step 1 is to get that parent function drawn. And we're just going to do the parent function of cosine. So I'm going to go ahead and get that drawn for us. Okay, now that our parent function is drawn, we're going to go ahead and move on to step 2. Step 2. And step 2 is called the middle. We have discussed this in previous videos. Step 2 is called the middle. And during the middle step, we're just looking at our d. What is our d in this particular function? It is -1. Awesome. So we're going to draw a line at -1. Because this line is affectionately called our middle line. And this middle line is basically going to cross directly through our new function. And the next step just works hand in hand with the second step. So steps 2 and 3 kind of work together. And it is called the amplitude step. And in the amplitude step, we're looking at our a. And our a in this case is 3. So that means we should be 3 above and 3 below the line at our highest and lowest points. So let's take a look at this. We have a high point right here at the from our original cosine equation, right? Because this line here is just cosine of x. The original amplitude was 1, right? We were 1 above and 1 below the line, that x-axis. But now we have to be 3 above and below our green line, our middle. So we have a high right here. So we're going to go 3 above. Let's do this in pink, I guess. Magenta, maybe. We'll go 3 above, 1, 2, 3 above for this high here. And then for this low right here, we'll go 3 below the line. So 1, 2, 3 down here. For this high right here, we'll go 3 above the line. So that would be 1, 2, 3. And we'll do the same thing here for this one. 1, 2, 3. And 1, 2, 3. And then all of those points that were originally on the line, on that middle line, will stay on the middle line. Okay, and then we will just connect those dots here. Okay, that's it, yeah, it's there, but it's not the best drawing, but it is there. All right, so let's look at our next step. Step number 4. Now, in our previous videos, I usually said do your shift first, then your period, but this one is a little bit different because our shift is not really the shift that you think it is. So we're going to actually do the period first. We'll do our period first. And I'll explain that. Okay, so the only time where we can look at this value here and say, okay, boom, that is our horizontal shift is only if this x is by itself. And it is not. So we have to get that x alone, and then we can do our shift. So when we get the x alone, we basically have to do the distributive property backwards. We have to factor out whatever is competing with that x. In this case, that is the number 1/2. Because if I factor that half out, I would get x plus 2 pi. True? Yes, because if I do 1/2 times x, that's x over 2. Now if I do 1/2 times 2 pi, that would be pi. So now we can look at this and say, okay, our shift is actually 2 pi, and our period, or our b, is 1/2. So our period should be 2 pi over 1/2, which is the same thing as 2 pi multiplied by 4. I meant by 2 gives me 4. That's what I meant to say. Okay, so now we've established that our period is 4 pi. In the normal cosine of x function, right? In this normal cosine of x function, my period is 2 pi. And that holds true because if I look here, let's see, that was magenta. If I look here at the start of the period and at the end of the period, the space in between here is 2 pi. But I need that space to be 4 pi. So all I'm going to do is just rename the graph or rename the x-axis. And all you have to do is just either erase what you already have there, or you can redraw the graph. Since mine is already messy, I'll just go ahead and redraw my graph. Now just do this for one period, so we'll do this quickly. Okay, so now we know that our period has to be 4 pi. So from the beginning to the end of that particular curve, that repetition, that sinusoid, it has to be 4 pi. So I'm just going to go ahead and draw that. And I can actually put a middle point in here. I can put 2 pi right there, right? So this could be my new factors. 2 pi could be there, and then 4 pi can be there. Uh-oh. All right, and now I will redraw the curve. It's literally going to be the same exact curve. Okay, and now our period is 4 because here's our beginning of the curve, here's our end, and it ends in a period of 4. Okay, this line here is still 2, and this is still negative 4, so our amplitude still holds true. And our middle line also still holds true for negative 1 because we have a line, negative 1, that goes right through the middle. I know it looks off for this a little bit. That's why it's always best to just go ahead and rename your graphs. I'll show you one like that as well. For example, I could take, let's take green here. Let's take green. And I can take this and say, okay, never mind. This is 4 pi instead of 2 pi because that's our period. And then I'll make this a little bit bolder so you can see it. That's 4 pi. And never mind, this is 2 pi. What's in between 2 pi and 4 pi? Oh, 3 pi. And change this to pi. Okay, and now your period works. And the last thing you have to do is the horizontal shift. We know that a horizontal shift has to be to the left worth of 2 pi. So all we're going to do is shift this entire graph over to the left 2 pi. So we just have to pick up each of these points here because we had points all along this graph, right? Pick up each of these points and just move their x-coordinate 2 pi over. So this point, it used to be at 0 for x value. Now it's going to be at negative 2 pi. These are supposed to be negatives, I'm sorry. All right, and then we can move this over. It used to be just pi, but moving it over 2 pi will give me a negative pi. This point here used to be 2 pi. Moving it over 2 pi will give me a 0. All right. This point here used to be 3 pi, but moving it over 2 pi would give me just a pi, which would be here. And moving this 4 pi over to 2 pi worth would be 2 pi. And you can literally draw this curve and you would be done. This is one period of this curve here that I'm trying to draw, and you would be done. I'm terrible at drawing these curves on the computer and by hand actually, but this orange line here would be your correct graph. Let's take a look at y is equal to 0.5 sine of 2x minus pi over 2 plus 2. First step, we already should know it by now, is get that parent function graph so we can have something to work off of. Okay, and here is our parent function of sine of x. Alright, so step 1 is complete. What is our next step? Our next step is to get that middle line drawn. Our middle line is our d. What is our middle here? Our middle is 2. So we'll get that middle line drawn. We'll do it in red. And we're going to put it right on y equals 2. Middle line drawn is complete. Okay, next step is our amplitude, right? Always the beautiful step 2 and 3 working hand in hand together. We have the amplitude, which is our A. We have to be half above the middle line and half below. So let's go ahead and move our graph accordingly. We'll do this one in wonderful blue, or aqua. We have to be half below for our highest and lowest points. So this is a high point right there, so we'll go half above. Have a low point here at 3 pi over 2, so we'll go half below. And anything on that 0 line remains on our middle line. Sounds good. We'll go ahead and connect those like such. All right, so far so good. Next step is period. And remember that we have to have that x alone. And the x is not alone again, so we have to pull out that 2 so we can get x alone. All right, so now x is alone, and what does that leave us over here with pi? It will be negative pi over 4, true? Because 2 times negative pi over 4 gives me negative pi over 2. So yes, we have factored out properly. All right, now we know that our period is 2. I'm sorry, not our period is 2. Our b is 2, so we can plug that into our period formula. And if we take a look at that, our period is actually pi. So right now in our regular sine function, the period is 2 pi, but we need to just be pi. So we can do one or two things. We can either redraw this graph, or we can just erase our x values and make our period what we want it to be. I will do that way this time just so we can see it. So I'm literally going to take away these x values. Whoops, I knew I was going to do that. I'm going to take away these x values. And I am going to make our period be pi. So let's see if I can redraw the rest of that line real quick. Awesome. So what do we have to do? Literally, we would stick a pi right here and we'd be done with the period. We can go in and fill in these other blanks. That is totally optional, but the period is done. We can put in a pi over 2 here because that's in the middle. And because it's 4 terms here, or 4 little tick marks, I can go ahead and put pi over 4 there and then 3 pi over 4 here. Basically, all that's saying is, okay, I have 1/4, I'll have 2/4, I have 3/4, and then I have 4/4, which is a whole. See how that matches up? 1/4 matches up with pi over 4. 2/4 matches up with pi over 2, because you have to simplify that. 3/4 matches up with 3/4 pi, or 3 pi over 4, and then 1 whole pi. So period is done, and all we have to do is shift it. We have to shift it to the right, pi over 4. Literally, all I'm doing is going to move all of these points to the right, pi over 4. Right? We'll do that really quickly. Let's use, what have we not used yet? Every color in the rainbow is here. We'll use a bubble gum color, I guess. Okay, we'll move all of these over to the right, pi over 4. So this point will now be here. This point will now be here, and then we'll have it here, and then here, and then here. And if we were to connect these wonderful dots, we have successfully completed the final step, which is the horizontal shift. And we can get that horizontal shift after x is alone, and it will be right here. Okay, so this is y is equal to 1/2 or 0.5 sine of 2x minus pi over 2. Alright guys, that was graphing sine and cosine functions. If you want me to do any specific problems, please send them over to me and I will make a video for you for those specific problems. I hope you learned a lot today. This has been Go For It Tutoring. You have a wonderful day.